In our final video for this unit, we are going to analyze a system of inequalities that represent a real situation. This is sometimes called linear programming. So the word problem will be given to you. I will have the inequalities written, and I will solve them for y for you. So all of that will already be done for you. I do notice a typo where that should be a 20, but that's neither here nor there. I will also have the inequalities graphed for you in these types of problems. It doesn't mean you don't need to know how to do those, but it will be done in these problems for you. So, first problem. After school, Bob earns $10 per hour tutoring, $8 per hour as a cook. He needs to earn at least $120 per week. So that's greater than or equal to $120. But he can work no more than 20 hours per week, less than or equal to 20. So this is the number of hours, this is the amount of money. I've solved them for y and graphed them. The solutions here are all represented in this dark shaded region. That's the area that solves both inequalities. It's important on these problems to look and pay attention to the axes. This is the number of hours cooking. All of these numbers represent hours cooking. And then look at one thing I would do is look at my word problem again and write down here how much Bob gets paid for that. We see that Bob earns $10 per hour tutoring, $8 per hour as a cook. Since this is number of hours cooking, I'm going to write down in here $8. That's going to help me as I analyze the problem later on. And then same idea down here. This is the number of hours tutoring. I'm going to write down here $10 because I know he gets paid $10 per hour for that. So in this type of question, it's going to ask you a series of things. Some of it you'll need the graph for, some of it you won't. This first one, we do. Could you cook for 4 hours and tutor for 7 hours? This is just a nice way of asking, is that point part of my solution in the dark shaded region? So I look for 4 in the cooking column again. Don't just look at 4 wherever you want. It has to go with cooking. So can I work or cook for 4 hours, tutor here for 7 hours? Well, those two meet at this ordered pair right here. Can I do that? No. That's not going to meet both inequalities. So I would answer it just as no. That is not in the dark shaded region or the shaded region, the overlapping region. For the second example, I'll do in blue. How much money would you make? So this is a different question now. How much money would you make? It's not asking could this be a solution. It's asking if it was, how much money would I make? That's where my $8 for cooking and $10 for tutoring comes into play. If I cook for 4 hours and I'm getting paid $8 per hour for cooking, I have to take my 8 times 4. If I tutor for 7 hours and I'm getting paid $10 per hour for that, I will add my $10 per hour times 7. I get $32 for cooking, $70 for tutoring, add this together, and I have a total of $102. Now, some of you look at it and say, well, that's obvious, that wasn't too difficult, and I agree. But you'll lose points if you don't show work. You must show this work to get full credit on a question like this on our quizzes or our tests. And our last question is just continuing with the first one. Could we cook for 5 hours, tutor for 11? Just to show you the contrast. Here is cooking for 5. Tutoring for 11, those meet here. That's in my dark shaded region. It is in my solution section. So could we do this? Yes. It is in the dark shaded region. on the back. Apologize for the formatting issues here as well, but we get the picture. Again, it's a different type of problem because these lines intersect, these inequalities intersect. So looking at the graph, what's most important about the graph are 3 points. Your y-intercept, your x-intercept, and then your intersection of the two lines. My solutions are this dark shaded region in here. But because they're both solid lines, my solutions are also on these lines. Now, these three intersections, y-axis or y-intercept, x-intercept, and the intersection, these are all your maximums. So this is going to come into play in a minute. You want to consider what it's a maximum of. This represents the maximum hours in the mailroom. That's the maximum number of hours you can work in the mailroom while still meeting both requirements here. This maximum represents hours answering the phones. That's the maximum number of hours you're allowed to answer phones in this situation. This one, however, is the maximum combined, which we'll get to in just a minute, a question on that. And it's an ordered pair. In this case, it's 5, 3. So we'll answer that question in a minute. This is always your minimum, 0 and 0. So quickly going back up and looking at our problem, you're working at your mom's company to make some spending money, and you're going to answer phones and work in the mailroom. You can work no more than 8 hours in a week, and you want to earn $90 or less. That's all they can afford to pay you. So that's the balance we're trying to find out here. You're getting $10 for answering phones, so I can go down to my graph and label this as $10. And $15 for working in the mailroom. Here's my mailroom. I know I'm getting $15 here. So, as the boss is sitting here looking, they're saying, I want to balance this out. What if I say I want you to work the maximum amount of money you can make if you tell them, no, I'm not answering phones, I will only work in the mailroom. That means you are going to answer the phones for 0 hours. But the maximum for the mailroom is represented by your y-axis in this case, because the mailroom hours is on your y-axis. So that means 6 hours in the mailroom is the maximum number of hours you can work there. And at 6 hours at $15 per hour, 6 times 15 means you could get paid $90. And that's why they can't afford to pay you any more than $90. That's why you can't work 8 hours in the mailroom, because then they wouldn't be able to pay you. If you decide to just answer phones, that means 0 hours in the mailroom. That's the maximum answering phones is now 8 hours. Now you can work 8 hours in the mailroom or on phones. So you're working 8 hours on the phones, because that's all you can work is a maximum of 8 hours, but they can only pay you $10 an hour. So you're working 8 hours, but you're only getting $80. Whereas if you do the mailroom, you can only work 6 hours, which is less than what you wanted, but they'll pay you $10 more. And then our last one is, what if you decide to do both? You say, just schedule me for whatever you need. At that point, that's where we're talking about the intersection of our two lines. That's the max combined. And in this case, that means you would be working 5 hours answering phones and 3 hours in the mailroom. And since phones are $10 per hour, mailroom is $15 per hour. $15 times 3 hours, we can calculate to see how much they'd pay you. 50 plus 45, $95.